Plasma chemistry is a newly emerging and rapidly developing field of science. It looks at plasma, often known as the fourth state of matter. It has huge potential to revolutionize many chemical, industrial, medical, and energy processes. My name is Lingliang Zhang, and I undertook Project ExoTungsten. Project ExoTungsten is the investigation of a novel method of generating a chemically active plasma through high-energy electrolysis with a tungsten cathode. This process seemed to unexplainably facilitate a variety of unknown chemical reactions. I decided to split the investigation into two parts, qualitative and quantitative. The qualitative side would answer the question, what is the nature of a plasma? And I investigated the variables of gases produced, ions present, color, mass, and intensity of a plasma. On the quantitative side, I would answer the question, what are the optimal conditions? For this, I looked at the variables of voltage, current, temperature, and mass of solution vaporized. The first design of a plasma cell was able to demonstrate this phenomenon. However, it lacked the ability to deliver clear and comparable results. So the design process continued. We constructed a second, more controlled cell. But this still had problems with inaccuracy and unreliability. These weren't resolved until the third cell, where we made improvements to allow for a greater range of variables to be tested, and also for more stable and consistent results. The investigation proved very successful. I was able to not only determine the optimal conditions for this process, but also prove that this method is able to efficiently generate stable, chemically active plasma with a local temperature of over 1000 Kelvin. The implications of this are vast, and this process has great potential to advance the entire field of plasma chemistry.
How were the results analyzed?
In this investigation, I created a baseline set of variables, and then designed 27 trials in which only one variable deviated from the baseline each time. To ensure my results were accurate, the independent variable in each case was tested several times over a range of values, so a trend could be determined. During the actual experiment, I took data plots of a voltage, current, and temperature at 10-second intervals for the duration of the experiment. I inputted all this data into my computer, which was able to calculate the energy input and energy output of the system at each interval. I then took this and used a graphing program to mathematically model the energy input and output over time.
What were some challenges you had to overcome?
One of the most difficult aspects of my project was finding the equipment to create my setup. I started by asking my school, who assured me it was far too difficult and expensive of a project to complete. So then I emailed all the professors on the list for Auckland University and MIT with my proposal. After a while, I found a professor from MIT who was willing to help me, and hence spent my weekends, after school, and holidays at the lab there for a few months. Over time, I managed to borrow enough equipment from MIT, Auckland University, and my own school, McLean's College. This allowed me to constantly improve my experiment, consistently getting greater and more accurate results. Once I had gathered enough equipment and experience, I was able to create my own lab in my garage.
What have you found?
The experiment proved that the activity happening in the cell container was able to produce chemically active plasma, as it displayed many characteristic features. The chemically active nature of a plasma was confirmed through the formation of carbon dioxide, as well as the oxidation of tungsten to tungsten trioxide. These do not appear in the control experiments and would not occur under normal conditions. This is further enhanced by a variety of colors in the reaction solution, signifying different ion compounds are present. As for the qualitative results, there is a slight trend that shows the cathode exposure is proportional to the coefficient of performance, or COP. No relationship was able to be determined between the electrolyte concentration and the COP. The duration of the reaction proved to be inversely proportional to the COP.
What's the significance of this research?
The experiment proves that this method of producing plasma overcomes two of the great problems of plasma technology, in that it does not require a gas medium and that the artificial plasma does not rapidly degrade. Its unique characteristics give way for a variety of practical implementations into processes such as chemical synthesis, industrial production, fuel conversion and production, as well as medical sterilization. The investigation has proved that this reaction definitely has potential future uses, and further investigation with greater resources could see it utilized for greater benefit and advancement of plasma technology.
Was this experiment a success?
As I was able to draw conclusive qualitative and quantitative results and trends, as well as prove its viability for further research and potential technological implementations, I consider Project ExoTungsten to be a success. Thank you for watching my video.